Hi, we're looking at a kind of a statistical problem here. So the setup for the problem is that a bunch of pineapples that are packed in 3 large crates were weighed and evaluated against each other. And off to the right are the box plots that summarize the contents of each crate. So there are 5 questions here that we're going to evaluate, and we're going to go through each of them one at a time. The first statement that we're going to evaluate is whether or not the weights of the pineapples in crate 1 are the most variable. So according to this plot or this diagram, in crate 1 we go all the way from 1.5 pounds to 6 pounds, which is a 4.5 pound spread. So we'll write that down here, 4.5 pounds. In crate 2, we go from 1/2 pound to 3.5 pounds. So that's a 3 pound spread. And from crate 3, we go from about 2.5 pounds to about 5 pounds. So that's only a 2.5 pound spread. So within each of these sets, crate 1 has the highest spread between the lowest value and the highest value. So this statement is correct. Okay, so the second statement that's made that we have to check against the information that we're given here is whether or not the heaviest pineapple was in fact in crate 1. So again, kind of looking at these whisker plots, we see if we're just looking at the largest pineapple in each group, those are going to be at the very far ends of the whiskers. So we are looking only at the highest value in each of the 3 data sets. So in crate 1, we have the 6 pound huge pineapple. In crate 2, we have the 3.5 pound sort of average smallish pineapple. And then in crate 3, we top out at a 5 pounder. So according to this whisker plot, this statement is also true. Okay, so the third statement that we want to look at is this one here, that in fact the lightest pineapple was in crate 1. So lightest pineapple, crate 1. So in the previous question, we were looking at the largest pineapple far on the right-hand side of each of the whisker plot data sets. But in this case, we're looking at the far left-hand side. So we're actually looking at this piece of information over here on the left-hand side. What we see is that the smallest pineapple in all of crate 1 was 1.5 pounds. When we look at crate 2, we already know that this statement is false because crate 2 already has 1 pineapple in the 1/2 pound section. You know, over here kind of lines up. So this kind of screws up that whole statement. So we're already going to say, no, it is not crate 1, it is crate 2 that has the lightest pineapple. Okay, so crate 3, this statement, the fourth statement that we're looking at here, is asking whether or not crate 3 had the greatest median and the greatest inner quaternary range, so the IQR. So what we're going to look at here is first we are looking at medians, and we can see right off the bat that it's tied for the greatest median Okay, so it doesn't have the greatest, but it is tied for the greatest. So this statement could still be close to true. So now we have to look at the interquaternary range. So the IQR is the distance between the different quaternary ranges here. So it doesn't actually say how many pineapples are exactly measured. It's just the crate of pineapples. But as we can see here, crate 3 only ranges from 3.5 to 4.5. So it only has an interquaternary range of 1. Whereas crate 1 goes from 3 to 4.5. So it actually has a range of 1.5. So it actually, crate 1 has, it's tied for the greatest median. They have the same median, but it has the greatest interquaternary range. So that statement, as it was given, is false. Okay, so this is the fifth and final statement that we're evaluating. And here it is. It's asking, more than half of the pineapples in crate 1 and 3 were heavier than the heaviest pineapple in all of crate 2. So we're looking at two things here. The first and the simplest to just figure out very quickly is, let's look at the heaviest. Let's look at the heaviest pineapple in all of crate 2, which was a 3.5 pounder. Okay, so if we use that as a starting point, then we're just kind of looking at, what do all these lines on a box plot mean? So we know that the center line in the middle of the box is the median in each of these whisker plots. And we already know that the medians for crate 1 and crate 3 are tied at 4 pounds. And so this is actually kind of a definitions problem, right? So if you're looking for a median, you're saying that half of all of the data points are below the median, and half of all of the data points are above the median. So if half of them are above and half of them are below, and you know that the answer here is 4, then you do know that half of the data points in both crate 1 and crate 3 are above 4, which is larger than 3.5. So this, that more than half of the pineapples in crate 1 and 3 are heavier than the heaviest pineapple in crate 2, is true. Just, and honestly, it's just a matter of definitions here, and we're saying that, half of the pineapples are bigger than 4 in both crates 1 and 3, and that the biggest pineapple in all of crate 2 is 3.5 pounds. So we do know that to be true. So just looking at all of these questions all just kind of ask you about how to interpret the different lines on whisker graphs, and to interpret that data across different graphs, so that you can cross-compare boxes of stuff or whatever it is that you're actually comparing. Okay, that's it for now.